In addition to converting back and forth between the mole and mass of a substance, we can also use stoichiometry to convert between moles and particles, such as the atom, ion, or molecule, as well as the mole and liters of a gas. So for the mole to grams or gram to mole conversion, we know that the conversion factor that we use is the molar mass. What about for the other conversions? Well, for atoms to molecules, we have to use Avogadro's number. And this, remember, is just the number of particles in a mole, and that is 6.02 times 10 to the 23rd power. And all that little caret, this little triangle here, means is 10 to the 23rd power, that the 23 is a superscript. And we also need for a conversion factor between moles and gases. To do that, we know that the volume of 1 mole of gas at standard temperature and pressure, and standard temperature and pressure is also known as STP, is 22.4 liters. So the volume of 1 mole of gas at standard temperature and pressure is 22.4 liters. We're going to assume usually that we are at STP, and STP is 1 atmosphere and 0 degrees Celsius. And the reason why we have to specify this is that gases can change volume very easily at when the temperature changes or when pressure changes. So we have to define a temperature and pressure in order to have our 1 mole of gas be 22.4 liters. Let's practice a problem using one of these other conversion factors. And the way we're going to do this is exactly the same way that we would do any other type of problem. For example, let's say we have 3 moles of hydrochloric acid, HCl, and we want to convert this to particles. Remember that all of these are particles. So we have to convert it to particles or molecules, depending on what we're looking at. So we put it, are given over 1. The next step is multiply by a new fraction. Old unit on the bottom, so moles of HCl go on the bottom. And in this case, HCl, it's a molecule, will go on top. Be careful if you try to abbreviate molecule that it doesn't look like mole. And we have to figure out, well, do our units cancel? Moles of HCl, moles of HCl. We're left with molecules of HCl. That's what we're looking for. And we know that 1 mole of hydrochloric acid contains Avogadro's number, or 6.02 times 10 to the 23rd, particles or molecules. So on the top fraction, I'm going to write up here, so there's room, is 6.02 times 10 to the 23rd. Molecules in 1 mole. Notice how this number actually did not depend on the fact that we had hydrochloric acid. You use Avogadro's number no matter what you are solving for, what compound you have. So we solve this, and we end up with 1.8 times 10 to the 24th molecules of HCl. So again, we have the given over 1, old unit on the bottom, new unit on top. There are 6.2 times 10 to the 23rd particles, whether it's atoms, molecules, or ions, in 1 mole of that substance. Multiply across the top, multiply across the bottom, and divide. Let's do one more. This time, let's do something with gases. In this case, let's go liters of gas to moles. So we'll start with 25 liters of, how about carbon dioxide? And that's a gas, so we can do this, and we'll assume we are at standard temperature and pressure. We have to convert this to moles. Given over 1 times a new fraction, old unit, liters of CO2, go on the bottom. New unit, we're looking for moles of CO2. Liters of CO2 canceled, we're left with moles of CO2, that's what we want to find. And according to our chart, it says that 1 mole of gas has a volume of 22.4 liters. So 1 mole has a volume of 22.4 liters. That's just over 11 2-liter soda bottles worth, if you want to know how big that is. So picture about 11 big soda bottles. And we'll do this math. And we get 1.12 moles of CO2. So the process is still the same as we did with moles and grams. In this case, we just have different conversion factors. Again, you can see that with gases, it actually doesn't matter what gas we have. It's always going to be 1 mole is 22.4 liters. What if you were given a problem where you were told you had 56 grams of oxygen gas, and you needed to figure out how many liters of oxygen you would have? How would you do this conversion? Well, let's look at our table. Our table shows that if we start at mass, grams, we can't go directly to liters of gas. We actually have to pass through moles first. So we have to go from grams to moles, and once we get to moles, then we can convert to liters of gas. So this diagram is here not just to show you what we can convert to and from, but it gives you a guide of how to get from one unit to another. If you want to go particles to grams, you can't go direct, you would have to go particles to moles, then you would have to go moles to grams. And this is why it says mole is the key. Mole is a bridge. Okay, the mole is a bridge to convert one unit from another. So in order to go from one of these outside units to another one of the outside units, you have to go through the mole. Now let's see how this works. So I gave the problem 56 grams of oxygen, convert that to liters. So we start with our given, 56 grams of oxygen, and as always that goes over 1 because that's our given. I then draw a new fraction. Old unit goes on the bottom, so grams of oxygen go on the bottom. And the new unit that we are looking for goes on top. But we do not know a way to convert directly from grams of a substance to liters of that substance. But we do know how to go from grams to moles. So instead of putting liters of gas on top, I'm going to put moles of oxygen. And now I know that the top unit is not the unit I want, so I need to multiply by a new fraction. And the old unit, which is now moles of oxygen, goes on the bottom. And the new unit, I do know how to go moles and gases. I have that link. So I can put liters of oxygen on top. I now check that my units cancel. So I have grams of oxygen, moles of oxygen, moles of oxygen. I'm left with liters of oxygen, which is what I want. So I know I've set up my problem correctly. Now I have to plug in numbers. So I have this fraction here, which is comparing grams and moles. Well, when I have grams and moles in the same fraction, remember that that is the molar mass that we need to convert. Looking at the periodic table, I know that 1 mole of oxygen has a mass of 32 grams. As the molar mass is 32 grams per mole. Now we look at the second fraction. This fraction compares liters and moles. According to my chart, when I have moles and gas, liters of gas I have to convert to, I know that 1 mole of gas at STP is the same as 22.4 liters. And now I've filled in all my numbers, so all I have to do is the math. Multiply across the top, multiply across the bottom. And on top I get 1,254.4. On the bottom I get 32. I do the division, and I end up with 39.2 liters of oxygen gas. So that's it. Whenever you have a multi-step problem, all you have to make sure you do is you cannot go directly from particles to gases or to grams. You have to convert to moles, and then you have to do a second fraction, a second conversion factor, to go from moles to whatever unit that you want.